Hello, AI Research School. My name is Theophilus. I'll be walking you through our final project. I'll note that our team members are Jeff and Steven. To begin, I'll go to the help page. So we have a tool called the Open Polymer Prediction. Our tool provides end-to-end environment for training, validating, and serving random forest models on polymer properties. Now, our typical workflow is to prepare CSV with a smiles column and one or more numeric targets. You upload that CSV, which is optional, and start a training job from the UI. You will select a smiles column, targets, the featureizer, and random forest hyperparameters. Of course, you'll wait for the job to complete. You will inspect the artifacts, the models, the feature rankings, the residuals, and the logs, and you'll promote the model to active and use it to predict some property or download the model for offline inference. Now, the key components of our tool are the featureizer, which they are the kit based, or the lightweight smiles fallback, the trainer, the random forest regressor per label, which supports multi label batch and runs, the registry, which stores model versions and active pointers per label, and the UI, which you'll use to start jobs, to monitor runs, to inspect the artifacts, and predict using the active models. Now, we'll go to our dashboard, which is the app home, which summarizes the data statistics and recent activity. So, just very quickly, you'll click on that and you'll find yourself in the dashboard. In the dashboard, you'll see some of the distributions that we have for our training data. And some of these are FFV, density distribution, RG, TC, and etc. We'll note that those abbreviations come from the NeurIPS Open Polymer Prediction. Here are the observations. So we'll go to data and we'll see that ID is the unique identifier. The smells is the sequence-like chemical notation of the polymer structures. Tg is the glass transition temperature. FFV is the fractional free volume. Tc is the thermal conductivity. Density is the polymer density. Rg is the radius of gyration. So we'll go back to our tool, and hopefully you've now memorized some of what those things mean. To begin, you'll go to the jobs. That's where you'll start most of your journey into our tool. From the jobs, you can create a job, you can start a job, or you can view existing jobs and jobs that have failed. If you view a job that has failed, you can see that we accidentally selected a smiles column for training, but then it couldn't convert this column into a float. We'll go back. We'll see we have two jobs currently running and they're not completed yet. Now, even though they're not completed yet, we have some information already available from these jobs that we can use in our models. For instance, if we go to the models registry, we'll see that some of these jobs have not completed, but a step of them have already completed where we can already use the information. So, for instance, we have FFV information, we have TG information, and we have TC information. If we toggle the versions, we'll see the associated jobs that this active model comes from. Obviously, we can set active or unset active. If we look at this, we can also select any of these to be the active model. And obviously, the boldened information is the job name. You can also download the active model and use it for offline use. Now, what's now important is the prediction page. In the prediction page, you will select a property that is available as a model and has an active model. So for instance, let's do the FFE. We'll input some smile string. So for instance, we could input CCO, which is two carbons and one oxygen. Now we can select a CSV file, or we can put in a smiles column here. It's not necessary, but we can then just run our prediction. We'll see that we have a predicted FFV value. We can toggle a debug panel, and then we can simply run a model check, which features a small sample and runs the active model to show whether or not the feature and alignment is kind of consistent with the data that we provided. So we'll do that shortly. It will only take a moment, but then we get an abundance of information such as the expected features, that RDKit gives us. We'll scroll down. We also have the available descriptor columns here, and we also have some more columns. Well, we also have our example. So these are the information that we get from RDKit concerning the information about the smile string. So for CCO, these are some of the information that are available for that sort of compound. And this is our prediction for FFV. We still have some more information that we output here just to be more verbose about the information that we're passing into our model and the output that we get. So we have a prediction, and we can sort of look what that value is between negative zero point 0.5 and positive zero point 0.5 because that's where most of our data lies. Those are the points that our data is clustered around. That aside, we'll go back to the help page. The help page gives us a lot of information about how to use the tool, run artifacts, troubleshooting if you're running this from source. And we'll just come here and go back to the dashboard. We'll note that there are model or context dependent help. For instance, just click the question mark and you'll see some help information on how to use this tool. The same is available for the jobs page, so you'll just click that. Also, there's a shortcut shift question mark to open the same page automatically as well. Same thing for here. There's the help page. If we go to the prediction, shift question mark, we have that as well. And also for our help page, shift question mark as well. Now, if we go back to the jobs detail, we'll note that while the jobs are not yet completed, there's some information here that we can get. So we can get some feature importances, some residuals, and some logs and artifacts. To start a job, we will simply click on Start Job anywhere in the menu. We can use the repository train CSV, or we can use the one that we uploaded here and is part of our available uploads. So if I go back to starting a job, I can use either of them. It's not really important in this case, but we can select our smiles column and then we can select multiple columns that we want to train our data on. So we wouldn't want to select a smiles column in this case. We want to select all of the other properties. We can pick and choose, but I'll select all of them. As usual, we'll set a random forest seed 47. We can do 100 estimators, but I think in order to see the model complete or finish in finite time, or the job to complete in finite time, in about a minute or so, we'll just set this to, in fact, let's go to 2. There's no max depth. We'll enable the Morgan fingerprints. The bits will probably reduce to 32, so we can see it finish quickly. So we'll start that job. It's unknown. It's picked up by the backend or the server. In a moment, we'll probably get an output. I'll pause the recording. So in a moment, the job will be done. But while that's going on, we'll go back to our prediction thing. So we have a lot of these properties now available to predict. We'll note that more of these versions are available. We go back to our jobs page. There we go, it's completed. Excellent. So in this completed job, we see how much time it took. So it took about 202 seconds. We can click on these columns to see more information or download sort of the data that's available on the server. You can see how much time it took to download each of these models. But when we come to the bottom, we can see some more information that might be useful to us. For instance, for residual information, we can select either of these labels and see what the information is for that. So we can see the predicted versus the actual. Same thing for RG, same thing for TC, same thing for TG. And the same goes for density or for the feature importances. So when running the random forest algorithm, we can sort of see what information or what parts of the descriptor gives us the more weighting in our prediction. So for density, if we'll scroll to the bottom, we'll see that this data sort of contributed the most to that prediction. So if we go back up here, we'll see that we can toggle, let's say FFV. You'll see that these things got reordered. If we go to the bottom, we'll see that, hey, there's something a little bit different here now that is influencing our model's prediction. Same thing for, we can do the same for RG, for TC, for TG. And we'll see that this is very important because when we have sort of more contrived data or more larger data set, we want to see what is actually causing our model to behave one way or the other. So that's kind of the usefulness of having these labels being displayed in the debug section of the job. So you can still see the meta that you sent to the server and sort of where those things are cached. And you can also download and copy the metadata as well. So that's more or less the overview of our tool. And obviously, we'll still have some jobs running because these are more heavyweight jobs. But hopefully, that gives you sort of an insight of what we built and how that's important. Thank you very much for listening. Do appreciate it. Cheers.